Welcome back. So let's do an example here looking at the difference between two populations, between their means. Researchers wanted to determine if carpeted rooms contain more bacteria than uncarpeted rooms. The following table shows the amount of bacteria in a sample of carpeted rooms and the amount of a sample of uncarpeted rooms bacteria in uncarpeted rooms. And what they're measuring here is bacteria per cubic foot of air. So they pumped the air out of the room and filtered the bacteria out of it and counted bacteria per cubic foot of air. They did that for a sample of carpeted rooms and a sample of uncarpeted rooms. Now, before we even get into the numbers or anything, let's just think a little bit about why this is not matched pairs. Why is this independent sampling? And by the way, so actually let's look down at the data for just a sec. You can't exactly tell from the way the data is presented, because it just so happens that in this experiment they had the same number of samples of carpeted rooms as uncarpeted rooms. So we said N1 and N2 could be different, but they don't have to be. And if they're the same, and you get this chart of data, and so it looks like, well, how would I know that those are pairs or not matched pairs? So you have to think about the situation. You can't tell just from looking at the table of data. So let's see. Well, basically, remember, matched pairs is when once you select one member from the first population, that dictates who you're selecting from the second population. So there doesn't seem to be any connection, or there isn't any connection between picking an uncarpeted or picking a carpeted room to test and then picking an uncarpeted room. So your choice of a carpeted room does not affect your choice of an uncarpeted room. They're not being paired up. Now, how would this read if this had been a matched pair sampling? I can think of a couple of examples just with the same idea of carpeted and uncarpeted bacteria content. What kind of experiment with those would be considered matched pairs? Can you think of any situations where you'd have matched pairs? Well, one way I could think of that isn't quite the same as this, but that's the whole point. This isn't matched pairs. If you had both carpeting and uncarpeted areas of a single room, and if they were checking bacteria for the two parts of the same room and selecting a bunch of rooms and looking at the difference in the bacteria within each room, right then, as soon as you selected some uncarpeted area, then you've automatically selected the carpeted area for that same room, and you get matched pairs because they're both within the same room. Right? That's kind of like when we had the acne medicine being applied to two different parts of the same person's face. Once you pick the person, you've picked, both samples. So here, once you've picked the room, you've picked both samples. Can you think of another way you might be measuring carpet and uncarpet bacteria levels in a way that would be considered matched pairing? Well, maybe you've got a corridor. Maybe you've got several corridors, like in your hospital or whatever. And from each corridor, you pick a carpeted and an uncarpeted room. Okay, then there's some sense in which, especially if each corridor just had one of each, there'd be a sense in which these are paired up because they're part of the same corridor. So that, just off the top of my head, those are two ways I can think of. You could have something that sounds the same but is matched pairs. But in this particular example, that's not what we have. They're not being matched up in any way. We've just got a selection of carpeted rooms and a selection of uncarpeted rooms. So this is independent sampling. Okay, back to the data. Because it's not matched pairs, it would not make sense to get the difference and between the two values in each line, because there's no connection between this 11.8 and the 12.1 any more than between this 11.8 and say the 13.7 or the 12. There's just no correlation between the carpeted and uncarpeted rooms. So what we're going to do is we're going to get the mean for the carpeted rooms and separately get the mean for the uncarpeted rooms. Okay, and those function as our two sample means. So this is our x1 bar and this is our x2 bar. This is S1 and this is S2. Sample standard deviation, sample means. When we did this with the matched pairs data, it made sense to subtract because the two numbers across from each other were part of a pair, and we were interested in the differences within each pair. And so for that, we had this other column that was the differences, and we got the average of that column. So we had a single mean that was the mean of the differences. Here, we had to have two means, and what we're going to look at is the difference of the means. Okay, so it's similar idea, but we have to do things in a little bit different order when we don't have matched pairs. Okay, so I'd like us to do two things with this set of data, one hypothesis test and one confidence interval. So, you know what, I've been talking for a while here just about this example, and what we're doing here with both the hypothesis test and the confidence interval are very similar to what we've done before. We're plugging into the formula for the test statistic, getting a p-value, looking at whether the p-value is greater than or smaller than the level of significance, and similarly on the next page for the confidence interval, we're setting up a certain confidence interval with an alpha, looking up the t sub alpha over 2, plugging into the formula. So here's what I propose to do. I propose to stop talking right now and end the video and let you at least think about, if you don't want to work through these because you haven't seen them, that's okay. But the method's going to be stuff you've done a million times already. So think about what you think I'm going to do, and if you want to go out to work through these, and I would highly encourage you to maybe go off to scratch paper and see if you can predict what the steps are going to be and compare your answer to mine. Sort of like a build your understanding problem. Okay, so I'm going to stop talking, stop the video, and we'll come back and go through these in the next video.